Good afternoon. Number 1, show the end behavior using limits. For this question, f of x equals 1 divided by x squared. So the thought here is, take the limit as x approaches negative infinity. That means to consider what would happen to this function as x gets further and further and further to the left. Now you know this function, this is one of our basic functions, so you know that it's coming in towards 0 the further out you get. And that makes sense because the larger number that you square, 1 divided by an extremely large number, 1/10,000th, 100,000th, 1/1,000,000th, and so on, is getting closer and closer and closer to 0. Now that not only works for the limit as x approaches negative infinity, it also works when x approaches positive infinity. Same idea, same concept. You might also note here that the denominator has a degree greater than the numerator. The degree of the denominator is 2, the degree of the numerator is 0. So the horizontal asymptote rule is, whenever that happens, the degree of the denominator is greater, the horizontal asymptote is y equals 0. That's another understanding of what these end behavior limits tell you. That's number 1. Number 2, what is the domain? We know that we are not allowed to divide by 0. So, x squared is not equal to 0. Well, that means we can't plug in 0 for x. So, in interval notation, this is the domain. It's all real numbers except 0. Next, for number 3, let's consider the behavior as x approaches the points of discontinuity. Well, the points of discontinuity are the intervals of the domain that x cannot be, which of course here is again 0. So we will approach 0 from the right and approach 0 from the left. So a number that's pretty close to 0, that's positive, would be 1 divided by a very small number squared. Now remember that a fraction squared, a small number squared, is even smaller. In fact, it becomes basically 1 over almost 0. And almost 0, but not quite, creates an infinitely large answer. And the same idea applies when you approach 0 from the left. Because we're squaring the number, basically the same thing happens. It looks just like this information over here. We basically end up with 1 divided by almost 0. Whoa. Which is infinity. Now, we can use the information from the limits we found in number 2 and number 3, number 1 and number 3, to sketch the graph. We know there's a horizontal asymptote, that is the pink line. We know that there's a vertical asymptote because at 0, both coming from the left and the right of 0, we approached infinity. That's where those came from. And we just sort of connect the picture. And this is the picture that we know to be 1 over x squared. Number 5. Show whether the function is even, odd, or neither by finding f of negative x and f of negative f of x and applying the rule. So we have f of x first, just like it was given to us at the top of the page. F of negative x, once simplified, looks like this. Notice that it looks the same as the original. And so by rule, if f of x is equal to f of negative x, that means this function is an even function. To review your rule, remember that if f of negative x is equal to the opposite of f of x, then that's an odd function. If neither of those apply, then it's neither odd nor even. Number 6, I made up a function h of x is the square root of x squared minus 6. X squared minus 6 must be greater than or equal to 0 because we can't take the square root of a negative number. So in thinking about squaring a number and getting a number bigger than 6, we're going to have a number that is either less than or equal to the negative square root of 6 or greater than or equal to the square root of 6. Might I suggest you take a minute and try some numbers in each of these regions to confirm what I just said. You will find that numbers in the yellow region work in this function. Numbers in the blue region work in this function, but numbers in the green region do not work in this function. Number 7. We have a graph. This was a given graph. I made this picture. You got it as a given. What you want to do is analyze it from the point of view of limits. So, the limit as x approaches infinity means what's going on out here. And you can see that it's about positive 2. The limit as x approaches, let me say that again, as x approaches negative infinity, we're at positive 2. As x approaches positive infinity, we are also at positive 2. As x approaches negative 3 from the left, what happens to the function? It goes toward negative infinity. As x approaches negative 3 from the right, what happens to the function? As x approaches positive 2 from the left, the function goes up off the page. That's positive infinity. And as x approaches 2 from the right, the function goes off the bottom of the page. That's negative infinity. Because this function goes off the bottom of the page and off the top of the page, it's unbounded. The function that would look a little bit like number 7 would be one that had points of discontinuity in it, because we always look in the denominator for that. None of those functions would look very much like the one I gave you, but that would be the choice that would look a little bit like number 7. And then number 10 and number 11 I've given you to think about for solving. I won't go through that. You can. And if you're not sure about it, you can come see me with questions. Thank you for watching.